This video will introduce the Pore Level Petrophysics module in UTAPWeLS by presenting the basic features using a synthetic model. The following will be presented in this video: generating a synthetic grain pack model using sequential deposition, which will be accomplished by choosing the grain pack geometry, choosing a percent distribution of the grains, specifying the size of the container, setting up the deposition conditions. The grain pack result will be converted into a voxel image. Cement will be added to the image. The following simulations will be run on the model: percolation, permeability, conductivity, and nuclear magnetic resonance and T2 inversion. Opening the Pore Level Petrophysical module in UTAPWeLS, there are two available icons. It is the second icon, Generate Grain Pack or Sequential Deposition, that will be demonstrated in this video. The following slide represents a diagrammatic representation of how sequential deposition works. A grain is individually dropped into the box and finds its lowest energy point, and then another one is dropped. This continues until the box is filled. Now back to the UTAPWeLS Pore Level window. Clicking on this icon opens the sequential deposition window. The geometry of the grains can either be a sphere or ellipsoidal shape, or both may be chosen. For this demonstration, two spherical grains of different diameters will be used. To add an additional grain, I will click on the Add Geometry button. The first sphere will be given a radius of 0.04. The second sphere will have a radius of 0.05. The grains need to be normalized to make the grain distribution 100%. Clicking on Normalize Percent will give a 50-50 distribution for this example. I will change the percentage though to 60% for 0.04 and 40% for 0.05. The starting grain pack is a new deposition. To reduce the simulation time, I will make the container a 0.5 by 0.5 by 0.5. For the deposition process, the search iterations will be set to 200. The max overlap of the grains of the lowest attempt will be set at 1%, and the highest attempt to 6%. The number of stages will be kept at 4. All other values for the deposition process will be kept at default values. Click on Run and a command window will open and the simulation will run. When it closes, click on the Results button. The box in the upper right shows the total grains used. Below that, it shows the actual percentage of each sphere. The pull-down menu to the left shows that the porosity was reduced at each max overlap stage. Any of these conditions may be used, but for this demonstration, the final value will be utilized. Clicking on Select this pack for further processing will convert the grain pack into a voxel image. By Xing out of the sequential deposition results and the sequential deposition windows, brings us back to the Pore Level Petrophysics window, which is displaying the voxelized image of the grain pack. Clicking on the Grain Pack tab will show the grain pack as it was previously seen. The voxel image is a series of slices. This example has 50 slices as seen when this double arrow button is clicked. It jumps to the last slice. The image may be displayed slice by slice, or a specific slice may be chosen by inputting a specific layer. The image may also be shown in the X and Y plane as demonstrated here. Cement will be added to the image. Note that in the composition box it shows the porosity. By clicking on the cementation icon, another window is brought up. For the cementation preference, I will choose the body. The cement goal will be set at 5%. Click on Run and the cement result window will give an attainment percent. Since this is close to what I want, I will click on Keep this image for further processing. Notice that the porosity has been reduced with the addition of cement. The cement is seen within the body of the voxel image, which appears as a gray color. The next module is the voxel-based percolation simulation. The default values will be used for the simulation. Clicking on Run, a command window will open showing the simulation. When the simulation is finished, type an X in the command window as requested. The percolation process displays the capillary pressure versus water saturation during ordinary, X invasion, Y invasion, Z invasion, and the best percolation graphs. Xing out of the graphs and canceling the voxel-based percolation simulation window, we can see that in the voxel image pull-down menu, it is now populated with water saturation results in various levels of percolation. Clicking on a saturation level displays the water and hydrocarbon within the pores of the slices, as shown here. This can be seen in the slices throughout the voxel image in the X, Y, and Z directions. Moving on to the permeability simulation module, which is opened by clicking on this icon. This is also called the geometric pore approximation. For this simulation, all boxes will be selected. Clicking on Run will result in another command window showing the simulation. The simulation was speeded up to complete. The results show the following. On the left side, permeability, absolute versus water saturation under the various situations chosen. The results may be saved to a file by clicking on this button. On the right side, the pore and throat size distributions are displayed. The graph can be displayed in a logarithmic or linear scale. It can also be displayed as a histogram. All or individual graphs may be displayed as shown here. The results may also be saved to a file by clicking on the Save to File button. Canceling out of the permeability simulation window, we will now move on to the conductivity simulation. For this, the source will be the ordinary percolation and invasion percolation results in the X, Y, and Z directions. The default values will be kept. Clicking on Run and a command window will open as seen previously. The run took several minutes to complete. The resistivity index versus water saturation fraction are graphed. These results can also be saved by clicking on Save to File button. The final simulation in this video is the NMR simulation. Using the default values for a single phase in an isolated spherical pore gives a result of a single peak as shown here. The simulation using the voxel image will proceed as follows. The source, both the ordinary percolation and invasion percolation results. Since NMR simulation is computer intensive, the following parameters were changed to reduce the runtime for this demonstration. In the mode of spin calculation, the number of walkers were set at 20. Under T2 distribution, the end time was changed to 1000 milliseconds. Under CPMG pulse sequence echo time, the inner echo time was changed to 50. No changes were made to the CPMG pulse sequence. Changes in the recorded echo time. Start was set at 100 microseconds. Interval was set to 100 microseconds. The number of echoes was 50. After 7 minutes of running, the following results for ordinary percolation and the X invasion, Y invasion, and Z invasion percolation results were computed. This is the end of a brief introduction to the pore level petrophysics in UTAPWeLS. Thank you for your time.